Hello viewers, in today's class we are going to discuss yet another important problem from definite integrals, right? Here we have to evaluate this integral from minus pi by 2 to pi by 2 square root of cos x minus cos cube x dx, right? So viewers, here I have written the definite integral of absolute value function, but if we see this problem, we see that the absolute value function is not written over here, right? But when we will proceed further, we will see that we can convert this integral involving absolute value function, right? So this is a very interesting problem where the integrand in the initial stage it doesn't involve absolute value function, but in the later stage we'll convert this integrand into absolute value function, and we have to apply the concept of absolute value function to evaluate this integral, right? So let us start now. Let us first take this integral as I. Now let us take cos x common, and we will have square root of cos x and 1 minus cos square x, right? Okay, now we know that from trigonometry 1 minus cos square x is equal to sine square x, right? So now this integral can be written as minus pi by 2 to pi by 2, and we have square root of cos x times sine square x, right? And now this integral can also be written as minus pi by 2 to pi by 2, and we can decompose this integrand as square root of cos x times square root of sine square x, right? So now here we see that we have two functions. Let us take this function as f, and let us take this function as g, right? And from the definition of absolute value function or modulus function, we know that square root of say y square is equal to mod of y, right? And here y is sine square x, so now we can write square root of sine square x as a mod of sine x, right? So now this integral can be written as minus pi by 2 to pi by 2. Here we have square root of cos x, and then for square root of sine square x we can write a mod of sine x, right? So this is how we convert this integrand in terms of square root of cos x and the absolute value function, right? Now let us concentrate on the limits, right? So here we have the lower limit as minus pi by 2, right? So here we can take minus pi by 2. This angle is minus pi by 2, and this angle is plus pi by 2, right? So the lower limit is minus pi by 2 and the upper limit is pi by 2, and here we have the angle 0, right? So now we have to integrate from minus pi by 2 to pi by 2, right? So it means we have to travel from the fourth quadrant to first quadrant, right? So this is the fourth quadrant. So the fourth quadrant is from minus pi by 2 to 0, and the first quadrant is from 0 to pi by 2, right? And we see that or we know from trigonometry that in the fourth quadrant, sine function is positive. It is negative, right? So the sine function is negative in the fourth quadrant, and in the first quadrant sine function is positive, right? So now this term, that is the mod of sine x is equal to negative sine x. From the definition of absolute value function, mod of sine x is equal to minus sine x when x belongs to the interval minus pi by 2 to 0, right? It means when x lies in the fourth quadrant, then mod of sine x is equal to minus sine x, right? And mod of sine x is positive sine x when x belongs to the first quadrant, and x belongs to 0 to pi by 2, right? So what we have discussed here, we have discussed that the sine function is negative in the fourth quadrant and positive in the first quadrant, right? So in the fourth quadrant, when we travel from minus pi by 2 to 0, then mod of sine x is equal to negative sine x, and when we travel from 0 to pi by 2, then mod of sine x is equal to plus sine x, right? So now we can split this integral I as a sum of two integrals, that is I1 and I2. So now we can write I as I1, that is I1 plus I2, right? And I1 is from minus pi by 2 to 0, that is minus pi by 2 to 0, and we have square root of cos x and mod of sin x, right? And I2 is from 0 to pi by 2, that is 0 to pi by 2, and here we have square root of cos x and mod of sin x, right? Okay, so now we have to evaluate these two integrals, and from minus pi by 2 to 0, from minus pi by 2 to 0, mod of sin x is minus sin x. So here we have minus pi by 2 to 0 square root of cos x, and here we have minus sin x, right? And dx. And when we go from 0 to pi by 2, then we have square root of cos x, and 0 to pi by 2, so mod of sin x is equal to plus sin x, right? And now we have these two integrals. So now in order to evaluate these two definite integrals, let us find out the indefinite integral, that is square root of cos x and sin x, right? So this integral can be evaluated by substitution method. So let us put t is equal to cos x, right? So dt, that is minus dt, is equal to sin x dx, and here we can write minus dt. So I1 is here, since we have taken this as I1 and I2, so let us take it as I prime. So I prime is equal to integral, here we have square root of t because cos x is t, and here we have minus dt, and now we have integral t raised to half dt, and this is minus, here we have half plus 1, and this is half plus 1, and we have minus t raised to 3 over 2, this is 3 over 2, and this is minus 2 over 3 times t raised to 3 over 2, right? And again taking t as cos x, so we have minus 2 over 3 cos x, and here we have 3 over 2, right? So now this integral, it becomes, we can take negative sign outside, so we have minus 2 over 3 cos x raised to 3 over 2, and the limits of integration are from minus pi by 2 to 0, and here we have minus 2 over 3 cos x raised to 3 over 2, and the limits are from 0 to pi by 2, right? So now simplifying it, negative and negative becomes positive, so we have 2 over 3 and cos 3 by 2 x, and limits are from minus pi by 2 to 0, and here we have minus 2 over 3 and cos raised to 3 over 2 x, and limits are from 0 to pi by 2, right? So now we can simply substitute the limits, and we'll take the difference. So here we have cos 3 by 2 0, because x is 0, minus cos 3 by 2, and here we have minus pi by 2, and here we have minus 2 by 3, and cos 3 by 2, here pi by 2 minus cos 3 over 2 0, right? And we know that cos 0 is 1 and cos pi by 2 is 0, right? And moreover, cos of minus pi by 2 is equal to cos pi by 2, that is equal to 0, right? So here we have 2 over 3, and this is simply 1 raised to 3 over 2, that is 1, and this term becomes 0, and here we have minus 2 over 3, this term is 0, and here we have 1 raised to 3 over 2, that is simply 1, right? So we have 2 over 3 and minus, this is 2 over 3 times 1, 2 over 3, this is minus 2 over 3 minus 1, and 2 over 3 plus 2 over 3, that is 4 over 3, right? So viewers, the value of this integral is 4 over 3.